Hello and welcome to this tutorial. Today we are going to get some answers to some questions that I gave you in the last tutorial and be able to jump forward as we progress with our course, our topic, Longitudes and Latitudes. But before we progress, let's have a quick word of prayer. Loving Lord, Father in heaven, we invite you in this session as we have our minds to study Longitudes and Latitudes, as we dig deeper and even dive more and more deeper to understand this topic, make it clear. Just may I pray. Amen. Now, in the last tutorial, I left you with some questions. And basically, the question was about getting X, Y, DM, and KN. That's what we want to work out today in this tutorial. So I believe you have a calculator closer to you. So we shall be able to work out that. Now in the first case, knowing that our formula still stands, our formula will be L will be equal to theta over 360 2 pi r. In the first case, I'll quickly jump that. I believe you know how to be able to get D and DM. I'll just be giving you the answers to confirm. But I believe it's also good to get the method. It means, let me just work them out. XY, we have that. So it simply means the angle in between will be 43 plus 37. So 43 plus 37 gives you 80. That will simply mean, let me do it on a different paper so that we save. This is the paper for our tutorial. Now, I'll have this as L is equals to theta over 360 2 pi r. So in the first case we have XY. This will give us 80 over 360 times 2 times pi times 6370, which was our r. So that will simply be 80 all over 360 by 2 by pi by 6370. That simply gives me 88.94. No, 8894.20 kilometers. Quickly to DM. DM, simply you having that formula constant. DM, notice there's something explained about DM and I want to re-echo it. It usually confuses very many students. DM looks like this. We have 60 degrees and 43 degrees. And here we have 9 degrees to the west, to the north. D is here, M is here. Notice there's a 43 degrees angle. What is this one? It's in this case here. This 43 degrees. There's 43 degrees here, and this one is 60 degrees. But if I get 60 degrees, it will simply mean from the equator here up to M. And 43 simply covers from D to the equator. But I only want from D to M. What will happen is that I'll subtract these two angles. Basically, what is the rule that applies in those two? If I have an angle difference in the same two angles in the same hemisphere, I'll simply subtract the two, the larger one minus the smaller one. So it simply means DM, the length of DM will simply be 4360 minus 43 divided by 360 multiplied by 2 multiplied by pi multiplied by 6370. I'll have that as 1890.01 or 02 kilometers. But I'm giving them in two decimal places. But in mathematics, unless defined otherwise, always state the whole decimal. Like for example, in this case, it will be 1890.017047. This is your answer. Kilometers. Try to always leave your answer in all those unless stated otherwise. Then in the last case, we have Kn along the equator. Kn is also another special one. Just take keen notice. It's along the equator. So meaning our angle difference will be 9 degrees plus 15 degrees, because that's what covers those 2 points. This angle here. So Kn will be 9 degrees plus 15 degrees divided by 360 by 2 by pi by 6370. That gives us what? That is 9 plus 15 plus 360 by 2 by pi 6370. I'll find that as 2668.25936 kilometers. Have your answer in that manner. So that's it. Now today I want us to get how to calculate the distance along a small circle. All that we have been doing is great circles. Now today we want to look at how you can get that distance along a small circle. Now I'll quickly have my two-dimensional earth plane and all that is required in it. Now having that, I'll give an example of my small circle. Remember, small circles are circles that have a radius smaller than the Earth's radius. And then I draw two longitudes that I'll use to be able to give my explanation. So notice in this case, if I extend my circle like that, and I have its mean center, what I'm doing is what you need to be doing in any typical exam. So I'll find that this is my center. It means these 2 points, this is the angle. But the question is, it is simply to get, for example, such 2 points. If I have this I know it's directly the radius of the Earth, but what of this one? How are they related? This is a smaller radius. So it's simply, this is what we're going to do. We'll simply have the points, these particular points, defined from the center of the Earth, so that we may have a triangle that has a relationship, that will give us a relationship between r and this small r and the radius of the Earth. So notice what I've simply done is to draw a pyramid, triangular pyramid. This is what I've simply done. This is the R and that is the R, and this is capital R. Now notice this being point A, point A, point B, and then it's joined in that manner. It's a circular thing. We have this plane that is kind of triangle. Okay? And then we know this angle. This angle here is alpha. And we said alpha is simply the longitude angles. If you remember that from what we said previously here. This angle here, we know it. That being alpha, which is this, the longitude difference, or simply the longitude angle that gives the particular definition there of the longitude, we can have the following relationship. That being that this one is also alpha, I can as well as introduce another thing. This angle here, theta. This angle, theta. Okay? Sorry for this line, it's not the way it's supposed to be. I have that. So this line is somewhere also in between here. This one being this the center of the earth. So we have this, that particular angle. Notice this angle here has some similarity here. What type of angles are those? So in this case, you'll notice that these two angles are equal because they are what we call alternate angles. They are usually equal. So these two angles being equal, notice I have this. This is R, the radius of the earth, and I have that. Which trigonometric rule can I use to apply to get that? To get this R, the relationship between these two. This is adjacent, this is hypotenuse, because here notice it will be right angled. So it will be cosine of theta is equals to adjacent over hypotenuse, of which that small r will be equal to r that. What is theta? Theta is simply the latitude difference. The latitude difference. So this was just to explain on how the relationship is. So basically we know that to get the arc length is simply theta over 360 2 pi r. But in this case it's a small circle, r. But what is r? R cosine of theta. So if it's a small circle, the length will be theta over 360 2 pi r cosine of theta. And then finally, notice that this angle here is theta. But what we want is this particular angle. So it means this theta is not similar to this. So the final formula that we'll derive, we'll find that this angle here will be different to this. So to define them differently, I can, for example, call this one, let me say, most of the time we'll be using theta, theta, theta. So I can call this one alpha. Most textbooks will find that they are calling alpha, but if you call it anything, that nobody will penalize you. So it will be alpha over 360, the angle here, 360 2 pi r cosine of theta. So long as you understand conventionally what each parameter means, you'll be able to know. So the length of a small circle is simply the angle of the angle between the small circle times 2 pi r cosine of theta. So this is simply the relationship that gives you r and the radius of the earth. So with that, in the next tutorial, we shall be able to look at various examples of how to apply this formula. God bless you.